Hello my dear friends, welcome to my YouTube channel. Myself Dattu Patel, Assistant Professor from LJIT. Today's session we are going to start with our new unit which is System of Equation and Matrices. Today's lecture we are start with our first topic which is row echelon form and reduced row echelon form. Firstly, what is row echelon form? A matrix A is said to be row echelon form, then it is satisfy the following properties. First one, if there are any rows that consist entirely of 0, then they are grouped together at the bottom of the matrices. That means non-zero row which is lies above of the matrices and zero row which is lies in bottom side of the matrices. That is our first property. Second one, if a row does not consist entirely of 0, then the first non-zero element that row should be 1. It is called the leading element as well as pivot element. That means every non-zero rows has every non-zero element that is indicated by the leading element. It is not necessary leading element should be 1, but for the better row operation or better simplification of the matrices, we making the leading element 1. Third property, in any two successive non-zero rows, the leading 1 in the lower row occurs to the right than the leading 1 in the higher row. That means position of the leading element which is left to right means first row leading element is here, then second row leading element which is left to right means at here, third row that is again here, and so on. Means position of the leading element which is shown as a left to right side movement. Let's see here few examples of the row echelon form. First example, first row that is 1 1 0 0 1 0 and each and every elements of the third row that is 0. In this example, first property which is satisfy non-zero row which is lies above and zero row which is lies bottom side. Then here zero row that is inside in bottom side. Second condition, leading element which is 1 means every non-zero elements of the every non-zero row should be 1. Then here first leading element 1 and remaining, and in second row has a first non-zero element that is again 1, then position of the first 1 2 means left to right side movement of the leading element. Then all the conditions are satisfied, then it is row echelon form. Similarly, second example, 1 2 minus 1 3 0 1 5 6 0 0 1 4. In this example also all the condition is satisfied. Here each and every rows are the non-zero rows. That means if 0 rows was absent, then no need to satisfy the first property, it is automatically satisfied. Second condition, leading element should be 1, it is also satisfied, and position of the leading element which is left to right side movement. Then and every entries of the leading element means leading element 1 and below of the leading element must be 0 means except leading element remaining all the entries of that particular column at the bottom side of the leading element that should be 0. Then each and every conditions of this satisfy. Then these all are the matrices which is in form of reduced row echelon form. Let's see next topic which is reduced row echelon form. In reduced row echelon form, the first three condition of the row echelon which is also satisfied, and fourth one is a new property. Means every reduced row echelon form matrices which is also called the row echelon form, but convergence was not true. That means we cannot say the row echelon form which is reduced row echelon form, but reduced row echelon form which is also called the row echelon form. A matrix A is said to be reduced row echelon form, then it satisfies the following properties. First one, if there are any rows that consist entirely of 0, then they are grouped together in the bottom of the matrices. Secondly, if a row does not consist entirely of zeros, then the first non-zero number in the row should be 1. It is called the leading element as well as pivot element. Third one is in any two successive non-zero rows, the leading one in the lower row occurs to the right than the leading one in the higher row. First three condition which is same as row echelon form, and fourth one, that is each column that contains a leading one has 0 everywhere else in that column. That means every column has a leading one, and except leading one, remaining all the entries are as the bottom side of leading element and the upper side of the leading element. Each and every elements of the 0 except leading position. Let's see few examples of the reduced row echelon form. First one is a null matrices. Null matrices means each and every elements of the matrices are 0 here, which is also called the 0 matrices. Then 0 matrices, which is called the reduced row echelon form. Second one is a 1 0 0 0 1 0 0 0 1, that is identity matrices. In this matrices there are non-zero rows present but 0 rows are absent. That means first condition which is automatically satisfied. Then second condition, leading element present and first row has a first leading element, second row has a second position, second row second column has at that particular position, that is A22 position has a leading one, third has a third row third column has a leading element A33 position, and except that remaining all the elements are 0, means leading one bottom side 0 and leading one bottom and upper side 0, means all the conditions of the reduced row echelon forms are satisfied. Means these all are the examples of the reduced row echelon form. It is not necessary first element should be 1. It is our leading element, that is every non-zero rows has a first non-zero element. In fourth example, first element which is 0, that is not necessary it should be 1. In first every non-zero row has a first non-zero element, that is our leading element. Then in this case first row has a second column, that is that element, that is 1, that is our leading element, and remaining all the entries of that leading element, that is 0. And it is not necessary each and every column has a entries except 1, remaining all the 0. That means in this third column, that is -4, means third column there are the leading element was absent at that particular position. Any value that may be present, -2, -3, 2, 3, etc. Let's see one example based on the reduced row echelon form and row echelon form. In each part, determine whether the matrices is a row echelon form, reduced row echelon form, neither or both. First example, 1 2 0 3 0 0 0 1 1 0, 4 times 0 then 1, and all these entries of the row, fourth row, that is 0. In this example, first condition will be satisfy, 0 row which is lies in bottom side, non-zero rows upper side. In second condition, first leading element, remaining all the terms of that particular column are 0, and position of the leading element, that is left to right position, first row, then right, and every element has a every column has a leading element, and except leading element remaining all the entries are 0, means here all the conditions of the satisfy of the reduced row echelon form. That means the given matrices is said to be reduced row echelon form or a row echelon form. Reduced row echelon form, which is also called the row echelon, we call the row echelon, but converse was not true. Now second example, 1 3 0 2 0 1 0 2 2 0, 4 times 0 then 1, and last row has every element has 0. In this matrices, first condition which is satisfied, but second condition was not satisfied because first column has a one leading element and remaining except that bottom side has a non-zero element, means in position of the leading element which is left to right side movement, first left then right, that condition was not satisfied, means given matrices is neither row echelon form nor reduced row echelon form. Here row echelon form, that is in form of RE form, we can say that, or reduced row echelon form, that is also called the RRE form. Let's see third example. 1 minus 6 4 3 0 1 3 2. This is row echelon form. Fourth one 1 2 3 0 0 0 0 0 1. In this fourth example, first condition was not satisfied, means non-zero row which is lies in middle of the row, means first condition was not satisfied. That means we can say that it is neither row echelon form nor reduced row echelon form. Let's see one example. Find the row echelon form of the given matrices 0 minus 1 2 3 2 3 4 5 1 3 minus 1 2 3 2 4 1. First, converting the row echelon form, it should be leading element 1 in first row. In first row, first element which is 0. Then we cannot go for the with the help of 0 remaining entries making the 0. We can't apply with the help of 0. Then with the help of interchanging the row, means third row and first row will be interchanging. Then applying the row operation R1 3 and our matrix making 1 3 minus 1 2 2 3 4 5 0 minus 1 2 3 3 2 4 1. Now with the help of first leading element 1, remaining all the entries at that particular column becoming the 0 with the help of row operation. Then we apply R2 minus 2 R1 and R4 minus 3 R1. Then our matrix becomes 1 3 minus 1 2 0 minus 3 6 1 0 minus 1 2 3 0 minus 7 7 minus 5. Now in this particular matrices, first leading element 1 already exists. Now in second row, we have to making the second leading element, means becoming the minus 3 as of 1. Then with the help of divide by minus 3 as well as interchanging the row as you like. Here second and third row will be interchanging. Then it will give you 1 3 minus 1 2 0 minus 1 2 3 0 minus 3 6 1 0 minus 7 7 minus 5. Here again our second leading element, that is minus 1. Then making the 1 multiplying with minus 1 to the second row. Then it will give you 1 3 minus 1 2 0 1 minus 2 minus 3 0 minus 3 6 1 0 minus 7 7 minus 5. Now with the help of that leading element, remaining entries in bottom side of the leading element to making the 0. Then with the help of row operation, R3 plus 3 R2, R4 plus 7 R2, then our matrix becomes 1 3 minus 1 2 0 1 minus 2 minus 3 triple 0 minus 8 and 2 times 0 minus 7 minus 26. Now first row and second row has a leading one, but third row does not have a leading one. Now to making the third row as a leading one, then interchanging the third and fourth row, that is R3 R4, then our matrices becomes 1 3 minus 1 2 0 1 minus 2 minus 3 0 0 minus 7 minus 26 triple 0 minus 8. Here leading element was not a 1, then multiply with minus 1 by 7 R3, then our matrices becomes 1 3 minus 1 2 0 1 minus 2 minus 3 0 0 1 26 by 7 triple 0 minus 8. Now first three column has all the conditions of first three row has all the conditions are satisfied, but fourth column does not satisfy, means for the making the leading one in fourth row, for that divide by minus 1 by 8 to the fourth row, that will give you 1 3 -1, 2, 0, 1, -2, -3, 0, 0, 1, 26 by 7 and 0, 0, 1. This is our the row echelon form, that is our exactly which we have to find. Now let's see the one more example. Find the reduced row echelon form of the following matrices: 1, 2, -3, 1, -1, 0, 3, 4, 0, 1, 2, -1, 2, 3, 0, -3. In this particular example, first converting to the row echelon form, then after we go for the reduced row echelon form. Up to row echelon form, following steps are the same as above example. Here in first row and first column, that is A11 position has a leading 1. Then with the help of that particular leading element, remaining entries of that column to making the 0. Then here applying the row operation, that is R2 plus R1 and R4 minus 2R1, that will give you 1, 2, minus 3, 1, 0, 2, 0, 5, 0, 1, 2, minus 1, 0, minus 1, 6, minus 5. Now, first leading element was present. Now, in the second row, to making the leading element, then with the help of second and third row will be interchanged. Then it will give you 1, 2, minus 3, 1, 0, 1, 2, minus 1, 0, 2, 0, 5, 0, minus 1, 6, minus 5. Now, here with the help of second row as a leading element and remaining all the entries of that column making the 0 at the bottom side of it, then with the help of row operation, that is R3 minus 2R2 and R4 plus R2, then our matrices become 1, 2, minus 3, 1, 0, 1, 2, minus 1, 0, 0, minus 4, 7, 0, 0, 8, minus 6. Now, in third row, to making the leading element 1, then divide by third row by minus 1 by 4. Then our matrices becomes 1, 2, minus 3, 1, 0, 1, 2, minus 1, 0, 0, 1, minus 7 by 4, 0, 0, 8, minus 6. With the help of that particular leading element, applying the position of the below the leading element, that making the 0. That means R4 minus 8R3. Now, with the help of second row has a leading element and bottom side of that particular leading element making the 0 with the help of row operation, that is R3 minus 2R2 and R4 plus 2R2, and that will give you 1, 2, minus 3, 1, 0, 1, 2, minus 1, 0, 0, minus 4, 7, 0, 0, 8, minus 6. Now, in third row, making the leading element, then with the help of multiplying with minus 1 by 4 to the third row, that will give you 1, 2, minus 3, 1, 0, 1, 2, minus 1, 0, 0, 1, minus 7 by 4, 0, 0, 8, minus 6. Now, with the help of that leading element and bottom side of the element making the 0, then applying the R4 minus 8 R3, then it will give you 1, 2, minus 3, 1, 0, 1, 2, minus 1, 0, 0, 1, minus 7 by 4, 0, 0, 8. Now, in last row, making the 8 as a 1 with the help of divide by 1 by 8 to the R4. Then it will give you 1, 2, minus 3, 1, 0, 1, 2, minus 1, 0, 0, 1, minus 7 by 4, 0, 0, 1. That is our row echelon form. Now, converting the row echelon form to reduced row echelon form means first three conditions are the same for the row echelon and reduced row echelon. But fourth condition, which is each and every column has leading 1 except that particular position, remaining all these entries making the 0. Start with the fourth column. In fourth column, last element which is 0, then with the help of row operation, then R1 minus R4, R2 plus R4, R3 plus 7 by 4, R4, then it will give you 1, 2, minus 3, 0, 0, 1, 2, 0, 0, 0, 1, 0 and 0, 0, 1. Now, for the third column has a leading 1, the remaining term making 0, then with the help of R1 plus 3 R3, R2 minus 2 R3, and that will give you 1, 2, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0 and 0, 0, 1. Now, in this second column, then R1 minus 2 R2, then it will give you 1, 0, 0, 0, 0, 1, 0, 0, 00100001. That is our reduced row echelon form, or that is our identity matrix for the 4th row and 4 column. That is also called the I form. This is all are the practice example. That is, try yourself. This is all about the topics row echelon form and reduced row echelon form. I hope you guys learn something from this video. If you like this video, then thumbs up. If you think that this video will help some of your friends, then do the share with them. If you want to watch more tutorial like this, then you can subscribe my YouTube channel, and whenever I upload the new video, you get notification. Thank you so much for watching me. If you have any query regarding this, then feel free contact me.